So this is kind of opposite of what I've taught you in the past, but right now I want you to ignore the equals 100 and I want you to just factor this left side exactly as is without getting one side equal to 0. So if we did that, we're looking for two numbers that multiply to give us 64. Those two numbers add up to negative 16.
Sorry, I was finding out.
It's fine. This would be negative 8 and negative 8. So this would factor into x minus 8 times x minus 8 equals 100. X minus 8 times x minus 8, because they're exactly the same, that is x minus 8 squared. Does that now look like one of the problems that we solved yesterday? So now we can square root both sides. What is the square root of 100? That's right, it's 10. This class is very talkative. So x minus 8 equals positive or negative 10. We add 8 to both sides. And that plus minus means positive 10 and negative 10. So that we can combine these numbers. One of them we do 8 plus 10 to get 18. The other one we do 8 minus 10 to get negative 2. Our two solutions are 18 and negative 2. Okay, we honestly can skip example 2. What I really want you to notice, think about the number negative 8 and how that number negative 8 relates to negative 16 and positive 64. Negative 8 times 2 is negative 16. Negative 8 squared is 64. Anytime you have something where the middle number is something times 2 and the last number is that number squared, it's called a perfect square trinomial. For example, if I should probably use a pen and not a highlighter. X plus 3 squared is x squared plus 3 times 2 is 6, 6x. 3 squared is 9. And if you start to see that relationship that 6 and 9 are related with the number 3. 3 times 2 is 6, 3 squared is 9. You can factor that down to x plus 3 squared a lot easier. So in these next 4 examples, they're asking, what should C be to make it be one of those perfect situations that we just talked about, a perfect square trinomial? So to do this, look at the middle number. What's half of that middle number?
7.
And what's 7 squared? 49. So C would be 49. On your assignment, it's going to ask you to find the value of C that would make it a perfect square trinomial, then write it as a binomial squared. So this would then factor into x plus 7 squared. Let's try number 4. First of all, what would C have to be to make that a perfect square trinomial? 16. Half of 8 is 4. I find it helpful to write that number up above, and then 4 squared is 16. So C would have to be 16, and then the factored form would be x plus 4 squared. Okay, 5 is a tough one. What's half of negative 2? Negative 1. What is negative 1 squared? 1. Number 6. What is half of negative 10? Negative 5. And negative 5 squared is positive 25. So when you take half of the middle number, that's the number that goes in the factored form in the binomial squared. Then square that, and that's what your last number is. Okay, now let's actually get to what we're really doing for today. We are solving by completing the square. If I gave you number 7 and said, try to solve this, we can't solve by square roots because we have x squared and x. So we try to factor. Two numbers that multiply to give us 7 and add up to negative 10. Those numbers don't exist, so we can't factor this. So we are going to create a completing the square situation. The first thing that we're going to do is say that this 7 is problematic. So I'm going to subtract 7 on both sides and get it out of the way. So I subtracted 7 on both sides, and I'm just leaving this blank. X squared minus 10x blank equals negative 7 blank. What number would I want to write here to make this a perfect square trinomial? What's half of negative 10? Negative 5, and negative 5 squared is positive 25. Now this is an equation. It's balanced. If I add 25 on one side, I need to also add 25 on the other side to keep the equation balanced. That's why I put a blank on the right side as well. On the left, this now factors into x minus 5 squared. On the right side, negative 7 plus 25 is... That's one of those that like my brain doesn't like to do. I don't know why my brain can't do that. 18. Now do we know how to solve this problem? We can square root both sides. Square root of 18. How can we split up the square root of 18? 9 and 2. So it is 3 times the square root of 2. Add 5 to both sides to get 5 plus minus 3 times the square root of 2. If you tried to factor number 8, you would get stuck. It's not factorable. This 5 is a problem. So I'm going to move the 5 to the other side and get it out of my way. So I'm going to subtract 5 on both sides and leave a blank on the left so that we can complete the square. Okay, so step 1 is take this pesky number and move it to the other side by subtracting 5 on both sides. Step 2 is figure out what number would complete the square. What number would make this be able to factor into a binomial squared? So I like to take the middle number, negative 18. What's half of negative 18? Negative 9. And then square that number, positive 81. And if I add 81 to the left, I've just made my equation unbalanced. To rebalance it, I have to put a plus 81 on the right side as well. The left side now factors into x minus 9 squared. This number is always half of your middle number and the square root, either positive or negative, of the third number. On the right side, negative 5 and 81 is 76. Now this is a solve by square root problem, just like we've been doing the last several days. Square root of 76. Let's see, half of 76 is 38, so I don't think 36 is going to work. Nope. Try 25 is definitely not going to work. Try 16. Nope. 9, I don't think is going to work. 4, yay, 4 works. This is the square root of 4 times the square root of 19. So it's 2 times the square root of 19. And then to finish this off, add 9 on both sides. X equals 9 plus or minus 2 times the square root of 19. Now, the first time I learned about completing the square, I was like, oh my gosh, this is sweet. We can solve any quadratic equation now by completing the square. Is there a catch? Is there any type of problem where you can't solve by completing the square? I mean, technically there's a way that you could, it just gets really complicated. The important thing is that second number has to be even because we need to take half of that second number. So if we had x squared minus 3x, that would not be a good problem for completing the square. But all of these, notice your middle number is even on all of these. Okay, let's try number 9. Do you want to try number 9 on your own? Sure. Pause the video, try number 9 on your own. Okay, so this one's a little bit different than the other two examples because we're starting with equals 3 on the right side. So my first step is move the unhelpful c value. So this plus 11 makes this unfactorable. Move that unhelpful c value to the other side. So I subtracted 11 on both sides and got negative 8 on the right side. Then step B is take half of the b value. So take half of negative 4 and then square it and add that number to both sides. Step C is to factor the left side. This is now a perfect square trinomial. So half of that middle number, that negative 2, that's how you factor it into a binomial squared. And on the right side, negative 8 plus 4 is negative 4. Then your last step is to solve using square roots. Don't forget your plus minus. The square root of negative 4 is the square root of negative 1 times the square root of 4. So we have x minus 2 equals positive or negative 2i. We add 2 to both sides to get 2 plus or minus 2i. Number 10, if we tried to factor this, it would not factor. To multiply to get negative 7, it'd have to be like a negative 1 and 7 or negative 7 and 1. Neither of those add up to 8. So that negative 7 is unhelpful. So I'm going to add 7 to both sides. That gives me x squared plus 8x. I know I'm going to complete the square, so I leave a blank, equals 5. Okay, to complete the square, we look at this middle number, this b value of 8. Half of 8 is 4. So 4 times 2 is 8. 4 squared is 16. That's what you add to both sides. Now this factors using that number, that half of the b value. So 4 times 2 is 8. 4 squared is 16. This factors into x plus 4 squared. On the right side, 16 plus 5 is 21. Then we solve by square roots. Go away. There we go. The square root of 21, I don't think that simplifies. Subtract 4 on both sides. Your final answer is negative 4 plus minus the square root of 21.